1, 3, 9, 27. Do I need to worry about it putting it over a fraction? Not in this one. We don't have to worry about it in this case because the leading term coefficient is 1, so it really doesn't have to be there. From there, we said earlier that it should have 5 terms, and this one does in fact have all 5 terms. So we just start pulling out coefficients. 1, 4, -6, -36, and -27. Start with 1. Okay. When you start with 1, excuse me. Oops, wrong spot. 1, 1, 5, 5, -1, -1. Not going to get there. Okay. Switch it to -1. This is, like I said, this is where if you had your own personal smartboard, it would make this so much easier to erase and redo. It's not that bad. Okay. -1, 3, -3, -9, 9, -27, 27, and happy day, oh happy day. Okay. So in this case here, you've got a 0 at -1, which means you have a term at x plus 1. What did that degree become for the new set of coefficients? Third. Now, if you look at those coefficients, you have 1, 3, -9, -27. Shouldn't that be something you should be able to group? Yeah. Start thinking ahead. You should be able to group at that point. Oops, let me rewrite. X cubed plus 3x squared minus 9x minus 27. When you start grouping, first bit you take your x squared out, and you have x plus 3, -9, and x plus 3. That means your other two sets of terms would have been at x plus 3 and x squared minus 9. So this now gives you all of your zeros. Your zeros are at -1, -3, plus or minus 3. So what should I write about -3? Multiplicity. So when I list it, I would say 1, 3, -3 with multiplicity of 2. And that's what we've been basically working. What's that? Oh, thank you. Yeah, I'm sorry. I thought this was an arrow for off the top of my head. Okay. That's what you've been doing. Could you graph that? Yes. Yeah. What happens to multiplicity?
It's like a
Yeah, it bounces. Oops, sorry. Let me change this to 2 pages here. So we knew that there's another point that you can plot. What's that other point? Y-intercept. So I can just say this is -27. Okay. Zeros are at -1, -3 multiplicity, -1, -3, and 3. Our tails are up. So the -3 has multiplicity. So as it's working its way down, it's going to hit here, go up through the 1, and go. Okay. That's what that should look like. Something, I don't know how big of a bump this is here. I know it just has to dive down and go back up. Just by the rules. The rules state that that's what that should kind of look like. Okay? Yes, sir? Because there's 2 of them? There's only 1 of them. It does, but that's where I got the multiplicity here for the -3, because the -3 is the one that's duplicated. The +3 is only there once. Yes, sir? It's 1 less than your degree. Well, it could be up to 1 less than your degree. So you could have 3 changes. Okay. It's for there. That's kind of what we're doing. All right. Excuse me. All right. X to the fourth, x squared minus 12, same idea. So at this point, you should start thinking, that's where I was getting at. There are multiple ways of going after these. And in this case, aren't your powers going down by half and then nothing to fourth squared and then a constant? When you see that, treat it like you would a regular quadratic. What times what's negative 12? You add together to get 1. So we have x squared plus 4, x squared minus 3. You okay with that? Where are your zeros?
Plus or minus I root 2.
It's not I root 2, guys. What's the square root of 4?
2. Yeah.
And then here it's plus or minus root 3. Can you graph that? Don't know how to graph imaginary. It's fine. But you can find zeros. I'm doing it right now in my head.
Oh, you're funny.
It's a bad joke. What happens here with the imaginary, if you put that in your calculator, it'll look like a W.
Let me try it.
Actually, let's do this one. Let's find all zeros. Find all zeros. It's kind of what we've been doing. I have x to the fourth, 6x cubed, plus 12x squared, plus 8x. What's the very first thing you're going to do? Take out the x, okay? Now, when you take out the x, what does that give you for a 0? 0. So we know right away when you factor that out. You know that this guy is a term, and you have a 0 already. Now you go with the tails. Figure your factors of 8. Plus or minus 1, 2, 4, and 8. Excuse me. Start with 1. Nope. 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 And then you have a 0 at negative 2. 0 at negative 2, your term is x plus 2. And now you're at x squared plus 4x plus 4. What times what? 4 that you add together to get 4. 2. So my other two terms then are x plus 2, x plus 2. Which means my zeros are at 0, negative 2. So my answer is 0 and negative 2 with multiplicity of 3. Okay? That's an odd multiplicity. What does the graph do? It just goes through it. Okay? It just goes through it. Alright? Because it's odd. Yep. It just goes through it. Yep. Evens bounce, odds go through. Alright? So if you graph that, it was 4, 3 was up, wasn't it? So it would just be something like that. I don't know where it changes in between. I don't know if there's a little any other variance within it, but for all intents and purposes, that's all you would know how to do, and that's fine. Okay. It's not imaginary or anything like that. Where's the other one here? Oh. Do this one. Yep, do that first because his first rule is GCF, and the GCF was the X, which means it is its own term, which means it's 0.
Oh, but you didn't do it to this one because.
You could. Did you catch there was a 0 for the X cubed?
Yeah.
Okay. Gotta have the placeholder there. Oops. Woo-hoo. Woo-hoo. Okay. I have a 0 at 1. Since this is a higher degree problem, what should I do with that 1 right away? Try it again. Always check it again and see if there's multiplicity. Doesn't hurt. Like now? Well, anything over 3rd degree. I mean, because once you get out of a 3rd degree, you go to a quadratic, which you should be able to factor in real quick, so you don't have to test multiplicity because they could just show up. I think we had one like that a minute ago. But anything that's, if you start from 4th degree and you go to 3rd, check it. But a lot of times you might be able to see right away those, if you notice some of those 3rd degrees we're getting, you can see the coefficients were groupable. So you can start seeing little tricks and stuff there. So that means 1 has multiplicity. Yes, sir. I'm sorry, what? Yeah, if you catch the coefficients, go for it. So now, I'm at 4 terms with a third degree, but I can't do anything with them yet. So might as well try it one more time. Oops. Yeah, so now I'll switch to -1. Go to 2. Nope. Was that 4? There we go. You all right? And now you're at what times what is 3 you add together to get -2. Quadratic formula. 2 things to multiply, the signs have to be the same. And if I do 3 and 1, that would be -2. Okay. So use quadratic formula here. Remember, it's opposite of b plus or minus the square root b squared minus 4ac. A lot of you guys are forgetting still that it's minus 4ac. So here you get 4 minus 12, which is what? Negative 8. So all over 2. So this is the square root of negative 8. What's the square root of negative 8? 2i root 2. Good. So now you know that this is 2 plus or minus 2i root 2 all over 2. Which means, what are you going to do?
Take out the 2.
So now we can list out all of our zeros. These are at 1 plus or minus I root 2. And then my other ones were at 1 with multiplicity of 2 and negative 2. So there's your 5 zeros.
How is this different from what we did yesterday?
Not really. You just have a couple of higher degree polynomials here and there. There's the way I look at when we start doing these things, it's so much easier just to go ahead and just start doing all of it. Right?
Oh, so I'm guessing we weren't supposed to find and then there would be a
Well, I told you to, though.
I know, but I'm saying according to the plan.
So what happens now if I do this?
It doesn't go.
What about it?
If those are zeros, what's the polynomial?
Oh,
We do it backwards.
Okay, you know how to do that. If those are zeros, yeah. If those are zeros, if 2's is yes, sir. X minus 2, good.
And X4 plus 4.
Very good. Notice, I did this on purpose. I only put 2i, but i's have to come in pairs, don't they? If you get one I, you're going to get another I. Because no matter what, the only way you can generate an I is if you took a square root. And you got a square root, it always over the equal sign was always a plus minus. So a lot of times what the textbooks and stuff will do is they'll only give you one of the I values, when in fact there's actually they're always in pairs. So this should be, and like you said, sir, you're perfectly right, there's x squared plus 4. In order to figure out what generated your I value, if it's just 2i or 3i, all you do is just square it and put a plus sign in front of it. Okay? So here, in order to figure out what the polynomial was, well, I'd start foiling. Well, this is x squared minus 2x times x squared plus 4. Well, foil that like you would anything else. You're going to get x to the 4th minus 2x cubed plus 4x squared minus 8. 4th degree polynomial, right? It gave us 4 zeros, didn't it? And that's how it works itself. I's come in pairs, and that's kind of the little trick there. Right, I just wanted to throw that at you, see if you can figure that out.
Is that what this is about? Finding the polynomial?
Of least degree? It's kind of what it's called. Find the right polynomial of least degree with this specifics there. Most of the stuff's going to be with leading terms of 1. We already did that one. Let's see if I had the other one here. I just did that. Okay. This is the worst case scenario. If there's 1 plus I, which means there should be a 1 minus I. Now, this is where it gets a little goofy. The other ones are easy. These two are pretty straightforward. It's x minus 1, x minus 2. If you FOILed all that out, you'd get x squared minus 3x plus 2. Are we okay with that? Yeah. Okay. Now, in order for those to be generated in terms of zeros, notice what we did. We put this 1 here, and it was x minus whatever that 0 was. It was x minus whatever that 0 was. It's the same thing here. It just looks weird. This is still I'm subtracting the 0. Okay? I'm still subtracting the 0 out.
He wants to like all the way back to so like all the way back to
We're getting there.
well, I'm
Okay,
saying-
we're getting there. We're not gonna have time to finish this one. No, we just don't have time to finish one today. That's fine. No big deal. I'll make sure not to give you this one today. We'll finish off on. We'll finish this one up tomorrow. I know we just have a few minutes, but this takes a while to get going into it. For right now, it's okay. I want to make sure we have the other stuff done. So, ow. Sorry, man.
oh my god. Oh my
I know that. I think it's a lot.
So what I did was I wanted to give you guys a couple, and remember, we haven't used the calculator for any of this stuff, but I wanted you guys to see how you're going to use the calculator when it comes to polynomial. What happens is there are some very, very, very easy table style problems that you're using your y equals stuff in the calculator, all right? You're looking at how long it took something to accomplish. You're looking for certain values in the table. It's super simple, okay? Those first group was just factor everything, giving me all the zeros. Those middle three were write the polynomial. Leading term coefficient is going to be 1. Okay, I'm not going to give you guys anything that doesn't have that yet. I'm so short on time. I don't know if we'll be able to get to that one. Might do a little bit of that tomorrow. This is really easy. And then, yeah, so we're still going to test on Wednesday. When we start thinking about the test stuff, it's basically this. I mean, this is all of it. This is factor everything, plot your zeros, things like that. Obviously, if I'm going to have you plot and graph something, I'm not going to have you plot and graph anything with imaginary. No, but you can still factor a 5th-degree polynomial, give me 5 zeros, you can have multiplicity and do all that stuff, and it'll work as we go from there. The writing equations, we'll do that one where it's the plus I tomorrow right away, and then I'll show you guys how to do one where if it's not a leading term coefficient, it's not 1. It's a really easy process. It's kind of like when we did the, remember how we wrote the equations in intercept form for quadratics where you had to solve for a? It's the same basic thing, but you're looking at a polynomial. So you're still substituting your values of x and y to get the value of a. It takes 2 seconds, so it shouldn't be so bad. And then we'll go from there. Thursday on the half day, we will start with the 9-4. It's perfect for a half day because it only takes about 10-12 minutes to talk about it. Just let you guys go. Friday, the 9-5 stuff, again, it's just adding, subtracting fractions. So it's a lot of factoring going from there. And then we finish out. We should be able to finish. My goal is to finish chapter 9 before Thanksgiving, which shouldn't be a big deal. Thursday. It's on a Thursday. It's the last Thursday of this month, I believe. It's half day for Thursday is the collab. It's our collab day. We have the 3 days. We have Monday and Tuesday. So we have Monday. Next year we'll have that one week. What's that? We've had this. days, for about 4 or 5 years now. Next year, they're moving conferences to those 2 days. Probably have 6 more days with it. So then it's just the whole week. So you guys get the week off, whereas it's still counted, it's still technically school days for us. It works out well. It'll be different. See how it goes. There you go. You can put that PDF on there real quick.